And we are live. Thank you for joining us, everybody. We're back with another amazing live stream with our founder, Shashank. Shashank, how are you?
I'm good.
So, how is the behind the scene in Fraction AI in this beginning of the year, 2026?
Yeah, it's been good. As some of the users already know, the kind of improvements we are seeing in the product, the new features, something that we have never seen in Web3 is kind of happening. So, really excited for the things we're going to launch. Yeah, like,
Hi, Oleg. Nice to meet you. Привет.
Привет. Nice to meet you.
yeah. So as you guys know, we have already had several live streams with great people from Sentient. We have already had Himanshu, we have had Sandeep, and now we have Oleg. So nice to have you, Oleg. Would be great if you could uh, introduce Sentient again, what you guys been up to, the great progress you have made in making AI available to all, and yeah, we can just start from there.
Absolutely. Hi, everyone. My name is Oleg. I'm the product lead here at Sentient. We have been doing AI research as a research and product lab for the past 2 years. First year, we've been focused more on safety and alignment. In the second year, we've been focusing on AI reasoning, and that has been our focus ever since and our focus now. Currently, we're interested in two things. We're interested in scaling, or rather just the concept of scalability of AI development, and actually cutting through the noise and being able to extract the most valuable solution, most valuable methods, such that we can evolve AI faster. And then the second thing we're interested in is in the evolution itself. There's been very frontier research in the past, just 1 month coming out, including our own, about how do you make AI systems self-improve. That is without human supervision or with minimal human feedback. How do you get AI systems to either self-engineer themselves or self-improve themselves, or autonomously go and acquire things for themselves in order to increase their own performance? So that is the two things that we're interested in at the moment. Would love to dig deeper into anything in between. Thank you for having me, Shashank.
Yeah, excited to be here. Yeah, great stuff. I mean, reinforcement learning is a great thing, and AI improving on its own, learning from signals is probably the holy grail. If we get to that, then we can recursively improve AI, and it just gets better over time.
Yeah, that's the scary thing from AI 2027, right? We're not quite there yet, but we are trying to move somewhat in that direction with safety in mind.
Yeah, definitely. So just to get started, I want to understand how you got started in AI. What was it about Sentient's mission that you decided to go on this journey of making AI available to all, making sure it's not centralized within like 3 or 4 labs that decide for the whole world how AI should be, and yeah, just about the journey.
Yeah, fundamentally, I believe in the freedom of software. So this is the standard open source paradigm that everybody, I think, buys, unless they're already in a closed source lab and making lots of money off of it. I'm a big proponent of letting everybody choose their own adventure and giving each person in the world the tools to do so. So when we talk about the AI stack, I want to make sure that the open source, there are open source models out there that are very powerful. There are open source agents and harnesses and tools that are very powerful that they can go ahead and set up by themselves with minimal dependencies on any external vendor. And so when we look at the open source model ecosystem, let's say, it is extremely rich at this time, with NVIDIA kind of leading now the efforts on the West, but then all of the amazing Chinese models coming out in rapid fire shows us that I think that sector is totally fine. And I know many friends of mine who are doing local hosting rather than using closed source models from the vendors themselves. And then on the agentic layer, we're also seeing lots of amazing work being done. But there's still lots and lots of gaps in terms of coordination and tooling and actually getting lots of these agentic things to production. So that's what we've been focusing on. We've started with, as I said, safety and alignment for AI models. And then later started transitioning into coordination and orchestration of multi-agent systems and how reasoning patterns can be evolved from multi-agent systems. And naturally, that's kind of the I think the biggest space right now. How do you make such powerful multi-agent systems and coordination systems available to as many people as possible? That's our goal in open source at this time. But more broadly, as I said, we believe in the open source mission. If there's something lacking in the AI sector, we're going to try and fill in the gaps as long as it pertains to AI reasoning.
Yeah, great goal. And Sentient is one of the few labs in the whole world, and even more so in Web3, that has trained its own models from scratch and continues to make improvements in that area. How has the learning been? Training your model from scratch or fine tuning models to a certain degree for especially for Web3 application, because like you guys are one of the few who can get into the nitty gritties of what works, what doesn't work, how was the experience, what matters more. Is it more about having good evaluation metrics so that you don't overfit? Is it more about the kind of data you feed into the system, or like, yeah, just happy to understand how it works.
I will tell you the same exact answer that would be given by anybody who is on the post-trading team at OpenAI or Anthropic, which is you need really good data and you need to be very patient. The secret sauce that people tell you is in how you are going to mix the data in post-training and where is the data coming from in post-training. What methods are you using? So are you able to collect high quality data from representative and generalizable reinforcement learning environments? And that's kind of the thesis right now, is that reinforcement learning generalizes. It scales and generalizes decently well. Are you able to collect enough JSON data or synthetically generate adjacent data in order to enhance your data mix for post-training? It is the same exact answer that anybody else would give. I don't think there is any particular secret sauce in the actual process. The secret sauce is in those individual environments from which you generate that data. So I don't know how much I can say about things I hear, but people come up with very, very original ways to generate data, and you guys know about it since you guys do do training as well.
Yeah, I mean, this was one of the things I identified about neural networks. Like we used to train them back in college, so it's more of an engineering problem rather than a maths problem. There's some things that just work, and there's just hundreds of things out there, and you identify what works and what doesn't work through practice. Some of that is documented, but there's just so many things you cannot document everything. So you just try it out, see what works, like just make it work. It's sort of black art at this point. So,
yeah, exactly. One thing that was a general, I guess, sentiment among everybody 5-6 years ago, when I was started getting into AI ML, is that over time you just start developing a feeling for what would work. and then people would ask, well, don't you have a very formal heuristic for this? And the answer is no. We just have a history, like a lab book of experiments, and we're just saying this stuff worked and then this one didn't. And then the explanation of why, well, we might guess that maybe the weights shifted because so and so and so. And so it becomes this kind of, I guess, people are doing vibe coding, but really the models are being trained. They're not being trained. They're being vibe trained. To some extent. It's obviously an overgeneralization. There's a lot of kind of science and understanding and like interpretability research that goes into understanding how weights are best influenced and how to do training in a much more precise manner, which all of the big labs are certainly doing. But if you are kind of on your own at your house with your own home lab, let's say, it will for you most likely be closer to vibe training. I mean, eventually you will arrive at something that works. There's some good science, some good heuristics that you can read and then make sure that it works for your use case. One thing that we did find, and for a less technical audience who might be listening to this live stream, this might be useful, is that if you're going to be post-training a model on task A, It obviously this is kind of a very obvious thing, but needs to be said nonetheless. Um, it might also make the model better at things B, C, that are adjacent tasks. Let's say you train the model to be good at finance, and then suddenly it becomes better at crypto. Okay, that's great. But the other thing to note is that as you do that, it might get worse at something else. So it might
Yeah.
get worse at creative writing. Oh no, that's so sad, right? And so you can't use the same model for creative writing anymore. And so all of these general agents that you're experiencing on ChatGPT platform, on Claude platform, on Gemini on Google platform, all of these generalized agents are kind of working on top of very well trained in terms of their data distribution, also general models, and it is very impressive how they're able to balance the capabilities in post training. So that's one comment, and something that you would encounter if you were to do some model fine tuning on your own.
Yeah. I believe like for all the major models out there, it's actually several models, and based on the query, it just reroutes you to the right model. Because otherwise, I just find it difficult for a model to answer everything in the right tone. And even if it could, it would have to be a really large model, and it would be a huge waste of resources to run every query through that large model when you could have smaller, more specialized models. And yeah, it's just seems better, but
Yeah,
who
so
knows?
that's a different argument, and I guess nobody will be able to tell you what truly runs behind ChatGPT when you click like GPT-5 thinking, or nobody really knows what runs behind Claude when you do like Claude 4.6 Sonnet.
Yeah.
So it's very likely that the labs are being somewhat truthful, and that is going to be likely the model responsible for all of the reasoning and kind of the synthesis of your answer. But you're right in that many times when you ask a question, there's going to be a very big and very bulky agentic layer that sits between your query and the answer. And so your query may have been seen by let's say 4 different models or 5 different models.
Yeah.
The majority of all of them but one being very small and very specialized models that are supposed to be, let's say, extracting content from a web page. That's its only job, and that can be done with a very well trained, let's say, 2 billion parameter model. Or the model might be exactly as you said, just the routing job itself, maybe a very small, well trained, specialized model. So yeah, absolutely. And I mean, all of it can be done by a big guy, but as you said, it would be very, very expensive.
Yeah.
So
And
whenever the big brains need to come in, then we use the big guys, right?
yeah, when we need to do cancer research or like some super important stuff, maybe then. And the reason I say it is because it was a few years back that I talked to this guy who used to work at OpenAI, and he told me, at least at that point, the way their models worked was the queries were routed to model based on the output you wanted. It was kind of based on output format as well as possibly the class of output, whether it's some medical advice, whether it's related to something finance. So there's like separate models for each of them. So of course he didn't fully divulge what was,
Right. It
but
may
yeah.
be completely different journeys entirely, so it can be completely different agents with different tools. It may just be completely different prompts, but the same model. Or you're right, it may be some tuned version of the same model or a smaller model if it's a simple task. Like you probably don't expect. Well, if you want to save money as the person hosting, right, you probably don't expect DeepSeek R1 to answer your "How are you?" You probably
Yeah.
expect Quen to
Yeah.
be to answer that.
Yeah. Very, very costly. Hello, that would be. Yeah.
The very expensive hello.
Yeah, and obviously it was a while back, so these architectures are always evolving, so you never know what they're using right now.
Absolutely.
So coming to architectures, how much do you think architectures matter? Because they all seem to converge towards same kind of solution space, as well as accuracies. So does it even matter as much?
So It matters. I think we're going to converge. So let's actually take a step back from that question for a second, and I'll kind of share how I think about this problem. And the problem is a more abstract one, which is given a question, are you able to create a complete execution graph that represents a perfect path from problem statement to solution? So if you ask me, compute the difference between the ages of person A and person B. So very likely your execution graph, well, you could just do it sequentially and say find birth date of person A, find birth date of person B, what is today's date, do the calculation, then do the second calculation. Well, the perfect execution graph would do some of those jobs in parallel, and that would merge once all the data is collected. And then for a more broader task that is very complex, your execution graph might have multiple parallel branches and might have 20 nodes, 30 nodes, 40 nodes. Think about your kind of ChatGPT Pro and the way that works and just how much thinking it does. And so if we're thinking about just optimizing the problem of creating this execution graph perfectly, or rather predicting this execution graph as perfectly as we can, all of the harnesses, all of these agent architectures, if we're talking about general agents, are going to try approaching, or the models are going to be trained in such a way that these agent architectures or harnesses, generic ones, are going to be able to generate such graphs, assuming that these harnesses use dynamic planning and are able to do parallel branching or sequential calls. So as long as your harness, like open code or Cloud Code, is able to support these kind of operations, all we're doing right now is we're just training the models to figure out how to make this execution graph closer to perfect. Right?
So I would say to that, execution graph is just a representation. It's just a way to represent your problem, probably like a DAG, and then you can execute that DAG.
Doesn't have to be a directed acyclic graph either, right? Like that's
just representing the problem as a graph. So then you can execute that graph and reach a solution. But it also assumes that all those models have same amount of learnability, so they'll be able to predict the graph by around the same level of accuracy, and that's how they are going to kind of converge to that.
Well, the thing is, everybody's always saying that the models are also going to converge to the same place. So that's actually my answer to you, which is, I think that we can create a harness, and we already have harnesses that are very generic, like Cloud Code or Open Code, right? These guys can do anything. They can do dynamic planning, they can think, they can reflect, they can do things in parallel, they can do things in sequence, they can spawn off because they have access to a coding environment, they can spawn off sub processes like child terminals. So there's no problem there in terms of orchestration anymore. It's just teaching the models to properly represent desired behavior from start to finish. So the models will converge eventually to something that,
So my question there was around model architecture. So are we assuming there that all model architectures have kind of similar levels of learnability? So they all.
So you're talking about model architectures, not agent architectures. Oh, I can tell you the answer to that question. We will wait and see.
Okay, yeah, that makes sense. And unlike the centralized labs, you guys have taken a different approach, a more decentralized approach to bringing AGI, which is giving more power to builders, and then builders can work on those harnesses and ensure AI is accessible to all. Would be happy to learn more about how it works and how you believe it's going to be better than the model we have right now.
So there's many things to talk about, but I will just say one, which is there is way too much BS out there in the world about what works and what doesn't. It is very difficult for anybody in the AI space And even worse, for somebody outside the AI space trying to look into the AI space and figure out what they should use or why they should use it. Because of the constant bombardment of new release,
Yeah.
made this obsolete, this made that obsolete, this made this obsolete again. And you never know what to believe unless you just pull it down and try it for your use case. And
Mm-hmm.
there are many use cases that are not well solved.
Mm-hmm.
Terminal bench is an absolutely monumental benchmark, which tells us that actually, regardless of how good Cloud Code or Open Code are,
Mm-hmm.
uh, agents are still not that great at using terminals
Yep.
when you take it to the extreme. And
Mm-hmm.
I would say that that's such a well-designed benchmark, one of the best benchmarks out there. And
Mm-hmm.
yet we can still come up with much harder operations that humans would be able to follow, we at AI won't. Similarly, you can look at a benchmark like Apex agents.
Mm-hmm.
It is a collection of dozens of environments and situations, and then questions associated with those environments and tools. And then it's a test of whether the agent would be able to properly get to a correct conclusion based on the tools it has simulated in that environment. And we
Mm-hmm.
see that the performance is also not that great.
Yep.
So while whatever we use these AI agents for, programming, writing our research papers, that we probably should not let the AI do completely unsupervised, and rightfully so. There is much, much more room to grow.
Mm-hmm.
And so, to your question more directly, when we say we want to unite people around the world to build AI together, I
Mm-hmm.
want it to be in two ways. First is I want us to together identify all of these hard reasoning challenges
Mm-hmm.
that are exposed by benchmarks like Terminal Bench or Apex agents. These are the two
Mm-hmm.
examples I gave. But there are dozens of these benchmarks which no model or even orchestration framework using different models is able to accomplish good scores on. So we want
Mm-hmm.
to identify very hard challenges that are representative of real world workloads that would be
Mm-hmm.
relevant in production. And then the second thing we want to do is bring people together to actually try out among all of the noise and all of these tools and all of these releases what actually work, and build
Mm-hmm.
some solutions and prototypes. And that would be a great start for everybody else in the ecosystem. Now,
Mm-hmm.
if you bring that many people together, one of them bound to have kind of the approximately best solution that there can be at this time with the current models. And
Mm-hmm.
then with all of that, you're able to also generate data to
Mm-hmm.
train the next generation of models, and you can do it again and again and again and again, so
Yep.
that we speed up the whole iteration cycle of improvement of models with each
Mm-hmm.
generation. That's what we're trying to do here. We're trying to recognize the hardest challenges. We're trying to bring people together to try and solve them, and then
Mm-hmm.
their solutions help generate data that can train the next generation of models. That is what I would say, uh, kind of Sentience community mission in a nutshell for AI.
Great. So, do you think a way of doing that is to make those reinforcement learning spaces available for each of those tasks and make the tools available so users can create their agents as easy as possible, give their insights, and then agents can interact in those spaces all the time and come up with the best possible solutions? Or,
It's
like,
one of them, yeah.
okay.
Yeah, that's why all of these all of these arenas are coming out.
Mm-hmm.
We have our own too, and that's why all of these lots of startups are being funded just to do this.
Mm-hmm.
Lots of startups are being funded just to build unique reinforcement learning environments for data collection.
Mm-hmm.
And the one thing that they're kind of missing is scalability. Are you able to scale the creation of such environments? And are you able to scale the creation of agents that participate in these environments? So
Mm-hmm.
those more kind of higher level questions is what we are interested in. So if
Mm-hmm.
somebody out there is building a reinforcement learning env, we want to bring lots of agents to that env. And then
Mm-hmm.
even higher level, let's just see how we're able to generalize the creation of reinforcement learning environments in the first place so that we
Mm-hmm.
can collect more data at scale.
All right. So, what would you say is the biggest problem in scaling those spaces? Is it like it's like a multiplayer game where there can be millions of agents interacting with each other as well as environment. So it's like difficult to account for their actions and the outcomes, since there's just exponential amount of interactions and exponential amount of players. So as those players increase, it's just becomes intractable, or like what's the issue there?
Well, if you have the kind of compute to have millions of agents play with each other, I
Mhm.
congratulate you. You probably don't have any problems with success.
Yeah.
So that's great. But no, I don't think that's. And I would ask you the same question actually. But I think the problem is not going to be in bringing volume.
Hmm.
The problem is going to be in bringing quality and
Hmm.
diversity on the
Yeah.
agent level.
Hmm.
So each agent should bring something unique in terms of how it interacts, maybe even some degree of unpredictability.
Yeah.
At the end of the day, if we're deploying agents in an area where they're interacting with humans, humans are very unpredictable. So it makes sense for the simulation to have a few actors that are very unpredictable.
Hmm.
So if you're having an RL environment where it's supposed to be this community of agents, kind of, let's say, managing a farm,
Hmm.
I'm sure one of the agents should probably be the guy who sets the barn on fire overnight accidentally, and everybody has to deal with it. So
Yeah.
that's one problem. But the second problem is that each reinforcement learning environment
Hmm.
is an extremely custom setup. And
Hmm.
so actually designing the environment itself in a way that makes it useful is very difficult.
Hmm.
So on the environment side, the RL environment design itself is a great area of research and exploration. But
Hmm.
even then, who do we want to participate in the environment? It's not about volume; it's about quality and diversity,
Hmm.
such that we can capture that data distribution well as the agents are participating in the environment. What do you think? I mean, you're in the training space, so how have you been working with RL, and how have you been thinking about RL environment research, even if
Hmm.
adjacent work?
I would say the biggest problem is reward function. For even for objective problems like trading, there's just so many things you want to measure. Do you want to look at max drawdowns? You want to look at Sharpe ratio, absolute returns? Some of those are correlated, but like all of them are useful. So how do you weigh which one is more useful for your application? And that's for objective truths. When you come to something more subjective, like say writing poetry, how do you decide which poetry is good? Even if you were to like train a small subset on human output and then use that to generalize on other outputs, yeah, I mean it's still gonna like converge to the same distribution as you trained it on, so it doesn't really work that way. So yeah, I mean, if we can find out a good way to come up with reward functions for like even for like five most useful tasks for humanity, I think it's done, because then you can just scale it up because your reward function is highly correlated with what actually works. And you can be sure of the outputs, since your reward function is good. It's able to select out what's good and what's not. And it kind of relates to what you said as well. It's more about quality and diversity, rather than just randomly scaling up, because yeah, you can have one agent and like a million copies of it doing the same thing, but it doesn't add any value to the system. So yeah, I would say it's more about reward functions. And this also comes from like experience with running some RL spaces of our own. We had like 4 million sessions so far.
Mhm.
Each session is where multiple agents interact and they try to solve a problem, come up with best possible answers to a solution. Some are adversarial games, so your agent has to choose the best possible actions and it learns over time.
Mhm.
Yeah, I mean, for objective domains, you can like still do it to some extent, but for subjective ones, it's super difficult.
Yeah, yeah. I think that for the audience who are still with us, basically what Shashank and I said is RL environments are hard. But I
Okay.
agree with you. I agree with you, right? Like all of the environments where the reward function is very objective and very clear.
Mhm.
Case in point, programming.
Yeah.
That's why our models are really good at those things. Is because creating the RL environments to simulate programming and like having a very clear reward function for something either working or not working
Mhm.
is very easy.
Mhm.
But your code either compiles or it doesn't compile. It's as simple as that, as an example. But like, did you book the right ticket, or did you make the right purchase? That is a little bit of a harder problem. That it's also going to be subjective. So, does the AI really understand those nuances? It will take a bit of time.
Yeah. And here's another example. So during our testnet days, we had this space called Rap Battle. A lot of our community members remember that. So you had to write instructions for your agent to write the best possible rap, and the users would come up with like few thousand word instructions on what a good rap is. They would give examples from Eminem, Jay-Z, and then others, and each of them had their own flavor. And so it was such a difficult job for us to create a model that could figure out which one of those was better than the others. And even filtering out junk from there is an issue, because someone could just say, yeah, write anything, and we'll keep running it even though the output is not very good. So yeah, that was one of the ways we try to solve that problem to some extent. But yeah, it's difficult. Subjective problems are super difficult. What are some of the RL spaces you are focusing on right now?
So I want to make one comment, which is we are working on data collection spaces that will hopefully become RL environments. Yeah. So we are reading all of the RL things that we can read, but fundamentally we are focused on right now just the first step, which is generalizing and scaling reasoning trace data collection for hard tasks, and then we can plug in RL on top of that easily later. And so the environments that we are currently looking at are mostly going to be around grounded reasoning. And if you talk to people out there who used to work at the big labs or kind of the big data companies, they will say, yes, grounded reasoning, for how relevant it is still not a very well solved problem. For those who are unfamiliar with the term grounded reasoning, it just means, can you give your LLM lots of data and ask it a question about that data, and then LLM give you the right answer? That is a very, very generic definition, but the way that it is represented in day-to-day kind of production use cases is ubiquitous and also extremely difficult. So for instance, you might log into, let's say, Volvo's portal. I don't have a Volvo. This is just an example. And you might ask the little box on this. I don't even know if they have a box. Okay, I'm just making this up. And you might have a box on the bottom right. And you ask it a question like, based on your terms of service and so, is it okay for me to lease the car for 6 months, let's say? Do you have a 6-month lease term? The answer is obviously no. Nobody does lease terms like that. But fundamentally, in order to come up with that answer, the agent actually might not just look at one page. The agent might have to look through tens or even hundreds of pages. And there are benchmarks out there, including one benchmark from our friends at Databricks called Office QA, where you get gigabytes of documents.
Damn.
And then what you have to do is you have to say, okay, am I able to build an AI system where I ask it a question about those documents, and it parses through gigabytes of files and is able to extract me an answer. So think about that task from the perspective of customer service, from sales, from just general reasoning for kind of problem resolution, root cause analysis if some investments are underperforming. There's lots of data, lots of documents that describe how a certain asset has performed over time, and the AI will have to go through all of those, think about which are the important KPIs, and then compute over them to give you an explanation for why an investment was underperforming. Right. So everywhere you see that problem is very ubiquitous. But the fun part is that the current AI systems, even the frontier ones, are actually not that great. They're okay, but they're not that great at operating at such a large scale of documents. So that's what we're working on right now. That's actually the topic of our first arena challenge, Challenge Zero, Grounded Reasoning. We're talking about all of the different ways that you're able to engineer good agents to reason over large data sets.
Yeah, because when I think about it, even grepping through like GBs of documents would take some time. So like making sure AI reads through it, search for relevant stuff, and then come up with an explanation for an answer to a question. Yeah, it's super difficult. And just
What are some environments that you guys have been working on at Fraction?
yeah,
Most
so yeah, for most recently, it's been around on-chain environments, like interacting with all protocols, DeFi, vaults, PubDexes. So you should be able to write your instructions in English, and it has to come up with that. It's funny because we talked about this earlier. We also came up with the same approach that you have to construct this sort of a graph of actions, and the reason is reliability, because probably 99% of the time AI can directly execute what you ask it to do. We can ask it to write code for your instructions and just call APIs of those protocols. But even if it fails like a few times, those mistakes are catastrophic. You could lose all your money, and user cannot see what their agent is doing. So that's why we had to come up with the structure where we had to decide our own language of representing what actions an agent can take, and then create that graph, so we can have some reasoning around what is it doing, and user can also approve the agent's actions, understand what it's doing. So yeah, it's around that, converting complex user intents into that actionable graph, and then being able to execute that graph integrated across all major protocols out there.
Makes sense.
Yeah, so like I said, like all models converge to like the same point, I guess. The way everyone kind of approaches solution, it's like 4 or 5 different constructs. If you can create a reasonable graph, then you can of course execute it, and then you can reason about it. Yeah, great. It also reminds me why grounded reasoning is so important. When we used to create AI models at Goldman, a lot of one of the biggest reasons of some models not going into production was, even if the model was performing well, you could not argue why model was doing what it was doing. It would take some action. Sometimes it worked, sometimes it doesn't, and you could never tell what it took to that action. But if you have grounded reasoning, it'll probably explain you the logic behind what action it took, how it came up to that explanation, that answer, and then you can be more sure that the reasoning kind of makes sense. Also true in root cause analysis, because LLMs right now are super overconfident. You ask them a question, they'll give you an answer even if they don't know it, and you can never be sure if that answer was correct. But with grounded reasoning, that problem should be solved. So yeah, great great work around that. How do you think the community can participate in that challenge right now? What do they have to do? Do they need to have a programming knowledge, AI knowledge, or they can just get started?
So the first challenge is a technical challenge. We have run an application season for what we call Cohort Zero. This is a very exclusive, small group of people who are tackling this first challenge first. And so these are AI researchers, people with PhDs, people with master's degrees, who are developers who have been engineering for a while. These are people who know how AI works and have interesting ideas to show. And so we're currently running this Cohort Zero campaign, and then participating in the Grounded Reasoning Challenge. We're currently doing it with the Office QA benchmark, actually. But we have plans to open up after Cohort Zero kind of finalize their submissions. We're planning to open up the leaderboard and the competition to the broader community. And we would be very interested in seeing what other people submit beyond the cohort, even though we're working with them more closely. Oh, nice. So is there something that I would say kind of an average non-technical person can do? I think the best thing that they can do is to read more and learn more. But if you're an engineer or if you're an AI developer, we absolutely would welcome you to join the challenge after kind of the Cohort Zero period ends, and then we publicize the leaderboards. Nice. And One thing that we're experimenting and thinking about right now is how do we make um, similarly challenging environments,
Mm-hmm.
but kind of make it more inclusive of people who are not engineers.
Mm-hmm.
So, case in point, some kind of strategic games or some kind of environments that emulate a task in a fun way, so that it
Mm-hmm.
feels like a game when it really isn't.
Mm-hmm.
And so we'll see if we have a few ideas, and we'll see if we're able to make one of them into reality, and see how the community reacts.
That's great. Do you think community who's not too technical can vibe code solutions to the first problem?
Very interesting question. So I think we're getting closer and closer to that being the case.
Mm-hmm.
AI is now getting very good at just writing itself,
Mm-hmm.
which is what we started the whole talk with, where we said, it's not quite AI 2027, but
Mm-hmm.
it's heading in that direction.
Yep.
And so what we're seeing is that AI can engineer some basic agents. AI by itself can also self-improve itself over time. It can fix its own weights. It can fix its own prompts. It can ask for different tools.
Yep.
And our latest release called Evo Skill actually
Mm-hmm.
allows you, as somebody who might be using Cloud Code or Open Code or Open Hands or any one of those agentic harnesses, to actually automatically generate really high quality skills
Mm-hmm.
for your agent, given that you have a benchmark that has a very clear evaluation criteria.
Nice.
And so if you were to participate in challenge 0 and you wanted to do, let's say, minimal effort, all you would have to do is you would have to install Cloud Code or Open Code, and then you would uh, install Evo Skill. You would download the Office QA benchmark, and you would run the agent with nothing on the benchmark, and then you just keep iterating the
Yep.
outputs to Evo Skill until it arrives at some local maxima. And the
Mm-hmm.
reason I say maxima is because these are all heuristic based algorithms that
Mm-hmm.
are not always reliable. So if you rerun it multiple times, you might arrive at a different answer. And
Mm-hmm.
that's exactly the same way as kind of the JEPAs or GEPA, however you want to pronounce it, works. And that's also how this Evolver thing that was released a few weeks ago works. And it's also how JEPA's own teams optimize anything works.
Mm-hmm.
And so these are approximations that are kind of taking and hoping to improve on where the agents failed. And
Mm-hmm.
that is going to the algorithmic maturity in specifically uh, that feedback loop is going to be something that will keep improving over time.
Mm-hmm.
But one thing that these algorithms will not be able to replace is they will not be able to replace any nuanced, deep human insight.
Mm-hmm.
And so when we look at, as a human, the kind of failures that our system has, our understanding and method of abstraction and also method of generalization is going to be different from that of an AI,
Mm-hmm.
especially if you just prompt it with a different word or give it a different seed. And
Yep.
so fundamentally, in order to squeeze out the best that we can out of the current generation of models, you will
Mm-hmm.
need that human insight. So
Yep.
will somebody non-technical be able to make an agent? Yes. Will they be able to even improve it by themselves with no knowledge of AI? Yes. Will that agent be useful? I don't think so, because it still requires that human insight. So maybe they have human insight and they use
Mhm.
this evolution algorithm as a co-pilot. Maybe then that agent would be useful.
Yeah. Yeah, I mean, I believe that's where we are kind of going to get over time as designing systems become easier and easier, and as we have platforms where you can like create agents very simply, it's going to be more about your insight. So when you can create an agent by just writing English, the better an insight you can come up with, the more value you add to the system. And if we can scale it to a point where any user can just give their insight, and there are small checks to identify, like it's like the insight has high probability of being good enough, and then then agent is created, and then it gets added to the system, and we look at the outputs and see how it's going. Then we can take it planet scale, because most people cannot code, and that number is going to increase, because with vibe coding, more and more people are not learning to code; they're just vibing. So if we can just scale this inside ecosystem, yeah, that's a great chance of arriving something super good.
Yeah, biggest value will come from insight. Absolutely.
Yeah. What do you think? Like, probably the last question before we move on to the rapid fire.
Sure.
What do you think the best case scenario for AI is? Like, if everything goes well, like you have planned, how does it look, and how is it different from how it looks right now?
What is the best case for AI?
Yeah.
The best case for AI, well, I will tell you what everybody wants, which is AI in everything. So you can imagine 5 years from now, this is year 2030, I would say everything that we use has AI somehow in it, that controls it or helps us use it, or hopefully eases our UX, but also makes us a little bit dumber in some way, right?
Yeah.
Because we have to think less about how we do things and how we approach things. AI will fix for us in many places.
Yeah.
So that's one. That's what everybody seems to want. That's what everybody's moving towards. But one thing that is also important about that arrangement is, if this AI that is going to be everywhere in every single service and platform that you use, that AI is going to know a hell of a lot more about you than you want to. And it is going to be very important to maintain that there's an option for you, not just in the open source AI world, but also just open source software world, to have open source platforms that you can use as replacements to self-host, to customize, to put AI in it or not put AI in it, however you feel comfortable. And when you put AI in it, you need to have a choice. Do I want to use a closed source provider, or can I use a very well specialized, at that point, probably a very powerful model that is, let's say, only 12 billion parameters large, compared to what we get with the trillion parameter models. And so I envision a future, a good future, to have both of these options, where first you have all of the kind of platform lock-in, closed source ecosystem platforms having AI integrated in absolutely every single device and platform that you might want to use as default. And it's up to you to configure and use those. And things are intertwining with each other, and people have partnerships over data, and everything seems to work seamlessly and smoothly. And yet you're sacrificing lots of your privacy, which you already are by just using any of these services and breathing air. But then there should be a secondary option where you're able to replace any of those services. That's the kind of health status, the required health status of open source software, but then also be able to integrate same seamless processes with AI. And that's going to be the health status check for open source AI.
Yeah, great. And I hope we definitely get there, because, like, without it, it's not really AI. It's more of oligopolization of everything. Because with a high certainty, AI is gonna be in everything, because it's a good abstraction layer. It makes interactions with everything easier. People can do a lot of things which weren't which they didn't even think were possible. I mean, if you ask people the amount of things they can do with a computer, and ask a developer, it's like 100x difference. And AI just makes that equal. So yeah, we're definitely gonna get there, and I hope it's the one where we have options.
Yeah. The key goal is options.
Yeah,
Exactly.
definitely.
I think many people will say, does open source AI win when it's more powerful than everything else? No, I think open source AI and open source software wins when it is an option, and it is at least as good, and that's important. You should not be making big sacrifices using open source software in order to gain control, configurability, and privacy. That's what victory truly is for open source, and that's what it has been for the past few decades.
Definitely agree with that. And with that, let's move on to the rapid fire round. The team has prepared some questions. I don't even know what those questions are, so let's see.
Let's do it.
All right. So in this section, Oleg, the first two questions are personal and fun, and the rest are AI. So with that, let's start with you, Oleg. So from what I understand, you beatbox, you break dance, you build AI agents. Which one, which skill is harder to master?
Uh, Probably dancing. Dancing is hard, but specifically breakdancing, because that implies lots of physical strength.
That's
So
interesting because, oh,
so
continue.
you're saying it's, oh, building a trillion parameter model is, it's so easy, but moving my hands and legs in sync, that's like super difficult.
In terms of time commitment required, I would say building a small model from scratch is much easier, as Andrei Karpathy has showed, than learning how to break dance.
Okay, so all the
All right.
dancers out there, you are doing something which is,
Not all dances, not all dances.
oh, okay,
Specifically, breakdance is very hard.
oh, okay.
So let's put that to the test. So which one, you said that building IRL things are hard. Which is harder to coordinate and direct? A group of 60 people breakdancing or an army of 60 AI agents in an agentic workflow?
Neither one is reliable. Both.
Okay. So this is for you, Shashank, and this one is hard. If you
Okay.
had to give up something, would you give up coding, vibe coding for 30 days or coffee for a year?
uh, I can still code, so I'll probably give up vibe coding, and like would help me think a bit better, because more recently I realized it's like, yeah, bro, do this, or yeah, change that element, or do something, and I've been not thinking as much as I would want to. So maybe giving up vibe coding for a bit would do me good.
All right, so coffee stays.
Of course.
Okay, so this is for you, Oleg. So you went from Princeton engineering to building decentralized AGI. Was it like a continuation, or did you have to like unlearn certain things in Princeton?
The only thing that you get taught at places like Princeton is just how to learn. That's the only thing that I learned.
Okay.
So there's no difference. If
All
you know
right.
how to learn, you can do anything.
Actually, that's the common theme I've seen with like all good learning institutions, especially at this point when knowledge is free. You just need agency to learn. Once you have learned how to learn, you can learn anything.
Yep.
All right. So this is for you, Shashank. Your experience in TradFi, did it teach you something about the need of decentralization, or did it teach you that like crypto and decentralized things need more structure?
Okay. You said a line in your question. Did TradFi teach me something about decentralization?
The need. It's important. Yeah.
Like TradFi never care, at
Yeah.
least in the past, they never cared about decentralization, or like didn't even think about it. It's a business. Their goal is to make sure they are a monopoly, or at least close to a monopoly, and do well in their business. So for there are a lot of good things to learn from a TradFi, how market works, especially at such a mature stage, what market participants care about, what's the buy side, what's the sell side, general macros, how these big firms run, what do they care about, what do their clients care about. So, and all of those things really help in building your complex systems.
Okay. So this question is for both. Now that we see a lot of on-chain agents are having institutional demand, do you think that certain crypto metas like meme coin give a bad image to like crypto and AI together?
Oleg, you want to go?
Well, for me, meme coins always gave a bad image to crypto, just because everybody around me is not a crypto person. So from an outsider, yes, the answer is yes. But I think more broadly, I think meme coins do give crypto a bad reputation. And I think one of the biggest things that we can do, and we should be doing, lots of companies are doing, is showcasing the power of crypto in bringing communities together and decentralization of effort and building real products that people use.
Yeah. I mean, one of the biggest negatives is it takes away the resources from other products that could have been focused on or even the mind share, because everyone around you is talking about meme coins. So if you're building something that's actually going to be adding long-term value, it kind of gets lost in the noise. So yeah, there's some negative repercussions to that. You could argue one of the positives could be bringing more mind share to crypto from the normies, since meme coins are easier to understand. But overall, I would say it's still negative.
All right. So it is also for both. Just last week, CZ from Binance said that AI agents will start making at least 1 million times more payment than humans. Do you think this is the case? And how soon do you think that AI agents will outnumber human transactions on chain?
Um,
You want to go first?
Probably I can. So I always compare it from TradFi numbers. I don't know about payments, but general transactions. In TradFi, New York Stock Exchange, most of the trades are automated because it's just more efficient. So yeah, I think similar thing should happen in crypto. Nobody should be running their own transactions, signing everything on their own. It's just difficult. You can make a lot of mistakes. You wake up in the morning, there's some message, and you just sign it without realizing what you signed. There can be a lot of issues there. Agents are much better at reading code, what the transaction is actually doing. So everything should go through agents. So yeah, I guess in terms of agents, most of those will be done. In terms of transactions, most of those will be done by agents. Not sure about payments per se, because transactions can be anything. It can be like trades. It can be anything.
Okay.
Oleg, you want to add something there?
I will answer it in the same way that that Amode talks about the capabilities of his models, which is I don't know when we're going to feel comfortable enough and in what areas letting agents handle payments and transactions.
Mhm.
And before we're completely comfortable, and I don't think we'll ever be completely comfortable with it. And so one
Mhm.
thing that we at Sentient have been building is this kind of payment rails paradigm. Basically, what that means is regardless of what your agent does in what environment, if it handles payments or if it doesn't handle payments, it still needs rules to follow. And those rules also cannot be strict, like strictly written as kind of old school rules. These can be kind of AI interpreted rules also, just so that there might be some reasoning about what this transaction is, why this transaction is, and then if it's something that seems suspicious, you can have the agent ask for human feedback before final execution. And this is true not just of payments, but of any tool calls that may be, let's say, very expensive. And so, at what point in time would we have agents executing transactions? Whenever all of these big corporations, big companies kind of provide CLIs and provide functionality for out-of-the-box, integration with agents, and when do people feel comfortable with actually using it? That time will tell.
Yeah.
All right. So last 3 questions. So this one also for both of you. Vibe coding is very popular lately. Would you advise the young person now to still continue to learn coding, or do you think that vibe coding is enough in the next 5 years?
uh, I'm a bit biased since my background has been in computer science, but I would still say learning the basics is super important. Unless you understand what's going on underneath, you will never really be sure of what's being done. You can build surface level stuff, but to actually build something meaningful, being able to get into nitty gritties, make small changes, understand what's going wrong, where do you actually need to target the problem, it's better to learn. Programming or the systems in general.
My answer is very similar to Shashank's. My background is in distributed systems, research, computer science. I would say that anybody who's learning computer science right now or is starting to code definitely has to spend a decent amount of time learning by themselves And as I said earlier, you have to learn how to learn. So if there's something new that comes out, especially something that AI wasn't trained on, something where in context learning might fail, you will have to go and fix and understand how it works. Now, that is kind of the answer that I want to believe, and that's the answer I usually give. But who knows what happens 5 years from now? Hell, who knows what happens in entire 10 years from now? It may be the case that 10 years from now, software is entirely dead, and we have orchestration systems that are capable of doing the work of humans faster, better, and actually even more creatively and modularly. We will never know. And at that time, what advice would I give? I would say, don't learn to code. The problem is solved, right?
Yeah, and we've kind of seen that happening because in a lot of universities, even the top ones, they don't really teach compilers or operating systems anymore because it's just too much in the details, not really required because you can abstract it out, work on the top level. So only those who are actually interested in those have to do those courses, and for their like degree, they don't really have to. So maybe it kind of becomes something like programming. You'll probably need to learn it at an abstraction where you're just giving instructions and not really need to get into the nitty-gritties.
Right. You approximately know which layer does what, where different jobs in the architecture would be, but neither do you have to be a programmer nor a real architect to give sufficient enough instructions for AI to do it for you. Possibly.
All right. Last two ones are very quick for you, Shashank. What's the last thing on your mind before you go to sleep that is not fraction AI?
Depends on the day, really. Mostly it's fraction AI, so can't remember anything else.
All right. So, same for you, Oleg. What's the last thing on your mind that's not sentient?
Probably food. I love food.
Oh, okay. In the cuisine in general, in special.
I'm thinking about new recipes to try. Is likely what I'm doing.
All right, that's good. Okay, so we arrived at the end of the session. Everyone, please follow Oleg. If you're not following Sentient, what are you even doing? And any last words for our audience?
Yeah, thank you for having me. AI is evolving way too quickly. Exciting things are coming. AI is improving itself. Environments are being built to collect more data to get AI to improve faster. So if you were interested in all of the latest on AI reasoning, follow us. If you're interested in Fraction's AI mission for training, follow Fraction AI.
Oh, damn.
And I hope everybody has a great day.
Yeah.
Thank you so much.
Yeah.
Shashank?
Thanks a lot, man. Really nice having you.
Thank you, everyone.
Yeah.
Bye, everyone. It's